6.4, factoring trinomials with leading coefficient other than 1, which we did see just a little bit of, and there's not really any good rules for this, so we kind of have to go through that separation of the middle term, which is usually just the x term by itself. It doesn't have any exponents with a variable, into splitting that very, very purposefully so that we can then factor by grouping, okay? So this is kind of how it ends up being for us. And we saw this at the very end, I think it was 6.3, where we should always be looking at all three terms to see if there's any greatest common factor that can be factored out, okay? Now, once you do that, if there is a greatest common factor to factor out, then you usually end up with one of two forms. This is kind of the main one that we're looking at. The other form right now for us anyways is where the A is just kind of a phantom one right there, okay? So factoring a trinomial by grouping. Okay? And again, this is the whole purpose of this is to find how to split this middle term into two separate values so that we can then factor by grouping two terms at a time, right? Because if we split this up into two separate terms, we then have a 4-term polynomial. Okay? So what we got to do is we got to take whatever the coefficient of x squared is and then the constant, the a and c value, you multiply these together. Okay? And then we look at factors of that product, whatever a times c is, and try to see if there's any factor pairs of that product. Again, that is not prime factorization at that point. It's just factorization. We're just looking at a factor pair between that product where the sum of the two values, the two factors, is that middle value right there, okay? Because when it is, and I feel like I'm doing this in circles, but that's on purpose, okay? Just I want to emphasize this. It allows us to split this middle term up into those two values, which then allows us to factor by grouping. If we can't find anything that a and c multiply, like the product of a and c there, where that product has two factors that sum is b, then we pretty much say that it can't be factored at that point. And sometimes if that happens, then we usually have missed the greatest common factor. Now you got to be careful because sometimes the c value, or like the product between a and c, that's going to be a negative. You have to be aware of that, okay? Because if it's minus c here, or even if the a value is negative and then you multiply that by the c value, you may end up with a product that is negative, okay? So you have to be aware of that because if you look at two products of a negative, one of the values has to be negative. On the other hand, even if it's positive, if let's say you do a times c and you get a positive value, you have to add two values, but sometimes this b value is a negative, then you have to make both values from the factors negative, okay? So you do have to be aware of that, and so I don't think I've emphasized this quite enough in this class, but this comes back to the whole idea that math sometimes is just what you need it to be. If you can force it to be what you want it to be to make things easier for you or to do whatever task it is that you're doing, then you can, okay? And then, of course, we looked at factor by grouping. We're looking for some kind of binomial that we can yank out of the two terms after the factoring. It comes out as a binomial. So eventually, right, we end up with some kind of format like this, right? X maybe plus something, or X minus or plus something else. But now you're going to see perhaps like a 2x right here, or some kind of coefficient of x in one of the two binomials. I know that's very abstract what I'm explaining right now, but I think we kind of covered that at least a little bit in the last lesson. So again, this is more the backwards movement right here. So if we look at some kind of binomials, let's just say x plus 2 and I don't know, x minus 1 like this, right? From this one, again, this is going to give us the trinomial in the end, right? But we actually have to distribute here like the x. We'd say, well, x times x there, and I am skipping some steps that I usually showed, would be x squared. X times negative 1 would be, you could say negative 1x. And then you could distribute the 2 there, into the x, so that'd be a positive 2x's. Show the phantom 1's there if you need to. And then the 2 times -1 is -2, right? Well, then we see that the two x terms can be combined. -1 plus 2 is positive 1. But of course, we're left with the x squared and the -2 there at the tail end. So this now, right, we're starting with something like this, and then it's going to, you'd say you'd split this middle term up into these two terms, and then eventually you'll end up, if you factor this by grouping, you'd end up with these two binomials, okay? But again, the coefficient of x squared now, right, you say, just to kind of emphasize this, we could have made this like 4 right there. Well, how does that change? Well, then you get a 4 right there, and a 4, and then 4, and then I guess a 3. Okay? So in one of the last lessons, 6.1, 2, or 3, doesn't matter, but we looked at something like this, and we said, hey, look, you're going to find factors of 12, right? So let's look at all the factors of 12, like 1 and 12. And then you had 2 and 6, and then you had 3 and 4. These are all the factor pairs of 12. So we're looking at each one of these factor pairs, and we got to be able to add the factors together, like 1 and 12. If I add these together, I need to get the middle coefficient, which in this case is 8, okay? Well, 13 clearly is not 8, so that's not going to work. So I'll try the next one, 2 plus 6, hey, that's 8 right there. And yeah, 3 plus 4 won't work, that's 7. Okay, so that's not going to work. So what this tells us then is that the 8x, I could have just split that up between a 2x and a 6x, both of which are positive in this case. So what we have now is x squared plus 2x plus 6 plus 12, right? So then we can factor this by grouping. We'd say, hey, look at this group right here. I can factor that out. I can see that there's an x. And I'm skipping some steps here on purpose. Again, if you need to see more of this stuff, then just go back to the last lesson and watch the video. But I could pull out an x from the x squared, so I'm just left with the x. And then the 2x, I would just be left with the 2. Now, remember, from this, we see this factor, x plus 2. It should be pretty much the same binomial factor for 6x plus 12 when I factor that out. Okay, but let's see. So I'm going to add this to 6x plus 12. I know I can pull out a 6 from there, right, from this binomial. So I pull out a 6. So from 6x, I'm left with just the x. And then from the 12, that'd be 6 times 2. See, and that it matches, x plus 2, x plus 2. And then I can factor out now an x plus 2 binomial from both terms. And then what were we left with in the other one? You got the x plus 6. Okay, and this would be considered factored now. So this one is the factored form, right? Now but remember, today's lesson, we're going to see not coefficients of x squared that is 1. And so from last time, from 6.3, we learned that you could have just taken these two factors, 6 and 2, and just kind of plugged them into this formula right here with the x's right there. But again, when the coefficient of x squared is not a 1, then we have to do this factoring by grouping stuff. So on this example, the first thing we're looking for is to see if there's any greatest common factors that we can yank out of all three terms, right? Now, there's one that should be fairly clear on this one because we got a 5 as our first coefficient of x squared, but I see the middle coefficient has a 5 in the ones place value and the constant has a 0 in the ones place value. So all of these terms are divisible by 5. So I'm going to split them up. And again, most students don't actually show this step, but it may help you until you get kind of used to it, okay? So that means that I could take the 5 and I'm pretty much splitting it from the x squared right there, okay? And then you got the negative 45, so I'd say, well, that'd be like negative 9 times 5, right? So there's my 5, 9 times 5, and we got the x, negative 9 times 5. And then the 70, right? So that you could say you're going to yank out a 5 from there as well. That would be 5 times 20, 14. Okay, so these 5s, I can see the green 5s here, and I'm skipping a little work, but I can yank each of these 5s out from the trinomial. Okay, so I'm going to pull this 5 out, and then what am I left with? The first term, x squared. The second term, negative 9x. And then the third term, positive 14. Okay, because again, these 5s were pulled out. They were factored out. Okay. All right, now that we've done that, now we look to see if there's any values that I can find, factors of 14 that would add up here to negative 9. So let's look at factors of 14 then, okay? So 14, I would split up, say, 1 and 14. Okay, let's say 2 and 7. That's all I can think of, actually. Now, the problem here is if I add this, right? Because the 14, by the way, is positive. 1 plus 14, boom, 15. 2 plus 7 is 9. But it'd be really nice if that was negative 9 because the middle coefficient here is negative 9. So what are we going to do? Well, we don't want to use just the positives here. Remember, a negative times a negative is also positive. And if I make the 2 negative and the 7 negative, now if I go to add those together, it is a negative 9. The 1 and the 14 is useless for us, okay? And what happens here is, I'm going to go back to the rule to skip little steps here, give us a little extra time. But it's going to give us the 2 binomials, where we got the x's, because remember, this coefficient of x is 1. We still got the leading 5 there. I don't think that's an academic term for this 5, but it's the leading, I guess, factor on this one. So what were the 2 factors of 14 that worked for us? Negative 2 and negative 7. Boom. This is the factored form of what we had in the beginning. Now, just real quick, is if you didn't realize that you could factor a 5 from these 3 terms, maybe you'd get like a 5x plus 10 right here, something like that. And if you did, that would have been fine. You would just have to have yanked out that 5 from that binomial right there to get this final expression. But you have to get this final expression. If you don't have this greatest common factor of 5 out, then it's no good. It won't give you full credit. Yeah, it may take some time to really figure this out, right? This is a whole new process for us. Okay, and like I've said before, the factoring bit, that's usually when we start losing students. Like, man, I can solve equations, I can graph, I can solve systems, but once we see factoring, it's like, what the crap is going on here, right? So if you feel like you're struggling with this, just understand that it's very common. And so a lot of these problems, they may take some time and patience, right? So you may have to look at this problem and be like, what is there a common factor for all 3 terms? And right, I mean, I kind of just spoiled the fun there, but it is 5. But you have to do this with all the problems. So let's go ahead and factor this one. Now, again, the first thing we should look to do here is to find any greatest common factor that we can. All right. Now, one of our problems, I don't see any x's in all 3 terms. That's kind of the first thing I would look for, because if I see an x on the final term here, that's unusual. And then I should know, generally speaking, that it's possible to factor that x out. I don't see any. The next thing I see is the coefficient of x squared is 3. Okay, now that means that if it's a common factor, if it's a greatest common factor for all 3 terms have to be divisible by 3. If this 3 wasn't prime, then I'd be looking for other values, but it's just prime. So negative 19 is not divisible by 3, neither is positive 20. So no greatest common factor from all 3 terms on this one. We have to go straight into the process that we have in this one, which is to first, in fact, I'll move this over a little bit. We got to take the a value, which is 3. That's the coefficient of x squared. And then the c value, the constant, which is positive 20. And I need to multiply these 2 together. Okay, when I do that, I get 60. Now I'm going to take this 60 and I'm going to split it up. Okay, so I want to find any pairs of factors for 60. And of course, the easiest one to think of, hopefully, is just one and the same number. I'll make that 6 a little better. There we go. And then you could say, well, you could divide it by 2. 2 and 30. And you could say 3 and 20, which I guess we've seen already. And then 4 and 15. And then 5 and 12. I know I've passed the one that we need, but I'm still going because, I don't know, it feels good. 6 and 10. I can't think of any others. It's not divisible by 7, 8, or 9, so we're good. Okay, so we got all these factors, right? But we need to add them together, and we need it to be negative 19. Now, the problem here is that these are all positives, so whatever I add together, they're always going to give me a positive value. So I got to turn and make these their opposites. They're negative values, right? Now, if I do this, and again, I would hope with some experience this would happen a little bit faster for you, but I know negative 1 plus negative 60, it's not negative 19, cross it out. What about negative 2 plus negative 30? Nope, that's not gonna work either. That's negative 32, that's no good. Negative 3 plus negative 20, negative 23. Nope, you need it to be negative 19. Oh, here it is, negative 4 plus negative 15. That is negative 19, okay? So my negative 19x, my middle term there, I will split it up into the two terms, negative 4x's and negative 15x's. Now, we talked about this before, because some students are kind of astonished that we can just do that. Yeah, we can do that. Why can we do that? Because I did not change the value of negative 19x. I only changed the way that it looked. This still, what I have in blue right here, still has the same value. So I'm just maintaining that same value. That's it. But now I have really what I'm going to look at as two separate binomials. This one and really this one, but I'll put a plus sign between there. So from here, now we're going to look for any factors that we can, any common factors between the two binomials that we have right now to pull out, right? And the first one I see on this one right here is a 3x squared and a negative 4x. I just have an x that I'll be able to pull out there. So if I pull out that x, then what am I left with on the inside? Well, we took an x from the 3x squared, so you're just left with the 3x. And you took the x from the negative 4x, so you're just left with negative 4. Okay, now this is kind of unusual for us to see right now. We haven't seen anything with the coefficient of x in the binomial. But since we've already factored the x out of this binomial here, we should expect to see over here in parentheses the same 3x minus 4, right? Well, let's see what happens. So from these two terms, I got negative 15x plus 20. Now remember, we don't want that leading coefficient to be negative, so I'm gonna yank this out. Whatever it is, it's going to be negative, okay? So I can put the negative sign out there first. I know that from these two terms, they're both divisible by 5, so I can yank out a 5 factor from both of these terms. All right, so from that then, okay, so we took out a negative 5x from 15x, so what would we be left with? Remember what we should expect? A 3x. There it is, 3x. And then from the positive 20, we yanked out a negative 5, so we now have a negative 4. Now, if you're confused on that, just think about this, okay? If you were to distribute this negative 5 back into that set of parentheses, what would you get? The same binomial that we had up here, okay? So, which is what we should get, because by factoring these two binomials out and changing this way that this looks, I didn't change the overall value of the expression, which is the whole point. I mean, that's kind of the basis behind a lot of mathematics. Can you change the way things look without changing the value? Yeah, we just barely did twice now. And now we know that we can factor out the 3x minus 4 from both of these terms. And then the other binomial would be whatever was left, the red x and the negative 5. Boom. We did it. Now, we did talk about last time, right, if this coefficient of x squared is a phantom 1, then you can just use the rule. If the rule thing doesn't work for you because there's a ton of rules that we've already have, I think that we're having you guys memorize. You can always use this method to do that, and then you'll get the same answers like we've seen before. Now, the last thing on this problem, if you had these, right, if you had the x minus 5 first and then 3x minus 4, you could, and you'd still get full credit. The order of these does not matter as long as you have them fully factored. Now, the last thing I want to emphasize on this one is you should always check, even though we did at the beginning of this problem, we looked for common factors, the greatest common factor to factor out of each of the three terms. Always just double check at the very end. And again, this does take some time, right? See if there's anything you can factor out from either one of the binomials. I mean, this one's good, right? Nothing's divisible by 3 or the 2's together. And this one's just an x minus 5. So we can't factor anything out there either. So we're in good shape, just like we thought we were in the beginning, but always just check in the end there to make sure. All right, so on this one, you guys tried it. And yeah, thank you for noticing. See, I just went right into my mode of just multiplying the a and c value on this one. So I created this table of factor pairs of 5, 4. There's quite a bit, and there's more than this actually, but I'm going to stop there because the pair we need is in there. But yeah, like some of you saw on this one, you could have factored out a 3. Okay, now I'm doing this not just because I made the mistake, but I'm going to continue doing it this way because if you don't notice in the beginning, like I failed to notice right here, then you have to be able to pull it out at the end. Okay, so here's how this would happen. Now, if you pulled the 3 out, I think it would have made the factoring a lot easier, but I didn't. So here we go, okay? So the ones that I noticed right here, and remember, I needed to add up to negative 48. And so I did get a positive 540 out of that. It was the 18 and 30. I know if I add those together, I'll get positive 48. So I'm just going to add them together as negatives to get negative 48 there, okay? And I can work from here, okay? So I could say, well, look, the negative 48, I'm going to split it up into negative 18y's and also negative 30y's. Now, I don't know. You could have put the negative 30 first and the negative 18y second. The order of these two doesn't matter because, remember, it's the same value. And since we were looking at factors of the combo, or the product of 12 and 45, it doesn't matter the order of these two either, okay? So what do we have now? Well, I got 12y to the power of 2 minus 18y minus 30y plus 45. And again, this is only if you do it like like I forgot to pull out the 3 in the beginning, right? All right, well, let's look at the first binomial that we're going to associate together here, combine. And so I can see that I would, 12 and 18 are both divisible by 6, so I'm going to pull out a 6 from both of these terms, okay? So, in fact, I'll put it down there. I'm going to take out a 6 from both terms. So the 12 would turn into a 2, and the negative 18 would turn into a negative 3. But also, the y squared and y, I can pull out a y from each of those. Okay, so that would leave me with 1y with 2y, and then we pulled this y out, so the negative 3 no longer has a y, okay? Now, if we've done this right, when we factor out from these two terms, we should get the 2y minus 3 in parentheses again. Okay, so let's do that. And again, I'll throw an addition sign between there. Since my first coefficient here is negative, I'm going to pull out a negative as well. And then 30 and 45, I'll skip some of the common factor stuff in there. I know they're both divisible by 15, okay? So what would be left in the parentheses? Well, negative 30 divided by negative 15, that would be 2, and you still got the y. And then 45 divided by negative 15, there would be negative 3. Just like we kind of expected with the 2y minus 3 there. All right, well, then what do we get? You get the 2y minus 3 that you can factor out from both of these terms. And then the other term would have been a 6y minus 15. Now, I talked about it last time. And again, I should have looked to factor out in the beginning here, but I forgot to do that. Now I have to look. I definitely have to look now. And so I know the 2y minus 3, there's nothing I can factor out there. But the 6y minus 15, I can factor out of that one. What can I factor out? A 3. Okay, so I'll show this split up. Okay, so like the 6y minus 15, that'd be like 2 times, in fact, I'll make it 3 times 2y. And then the negative 15, that'd be like negative 5 times 3. Okay, so from that, I could factor out a 3 from both of these terms. And then the 6y then is just left with the 2y. And the negative 15 is just left with the negative 5. Of course, that didn't affect the 2y minus 3. Okay, now I got the 3 here on the tail end. I believe that will work on Canvas, by the way. But if you find that it doesn't, just put it there in the front over here. I can leave it like this. Some math people get kind of freaky about just the way this is structured. Like I really don't care because it's still true. But you know, some people may say, you need that 3 in the front, otherwise you're going to mark out points. I don't really care as long as you know how to factor these out. Right now, I would say always expect there to be a greatest common factor in these, but that doesn't mean it always will happen. Like even this one, right? 9x to the power of 2 plus 3x plus 4. Well, I know 9 is divisible by 3, and there's a 3 right there, but the 4, it's not divisible by 3. So I know there's no greatest common factor with these two terms, okay? So what we're going to do is we're going to jump straight into our process, right? Take the a value, 9, and multiply it by the c value, which is 4, the constant. And this would give us 36 right there, okay? Now I'm going to split 36 up, and I'm going to see if I can just add 2 of the factors together to get 3, middle coefficient there, right? So 36, of course, 1 and 36, that's not going to work. Or 2 and 18, not kind of far away from each other. How about 3 and 12? Still no. 4 and 9? No. Well, it's not divisible by anything else, okay? And yeah, right here you can see 1 plus 36, that's 37. Okay, so again, that's no good. What about 2 plus 18? That's 20, so that's no good. 3 plus 12, 15, no good. 4 plus 9, 13. What if you made these negatives? It makes all four of those values negative. So this one is what and it'll say this on the assignment, you just write in prime, meaning that it can't be factored at this point. Of course, I suppose there are ways to do it, but we're not concerned with that right now. I like this problem because it's quick, but maybe you don't. I don't know. All right, here's this one. Now, this one tends to cause some confusion because we got some y's on both, on these two terms, right? And they got the x's on the first two terms. That's okay if that happens. And we've seen a problem like this already. So us seeing one like this already, hopefully that kind of helps us figure out what the crap is going on, okay? But the process is still the same. Pretty much ignore your x squared and your y squared for now. Focus on this middle coefficient and then adding those, or multiplying the a and the c value. Now, from this though, I'll try not to make the same mistake, and I will look to see if there's anything that we can factor out from all three terms. Of course, there's no letters, no variables that I can factor out. But I do notice that they're all divisible at least by 2. I don't see any other factors that's going to work there. And that's, I was looking at the 46 thing that's divisible by 4, but it's not.
Oh.
You have to get to 48 for that one. Okay, so of course 46 divided by 2 would be 23, which is prime, and 40 and 12 are not divisible by 23. So we're going to take out a 2 from each of these terms. I'm going to show again. I think it's more work than maybe you even need, but I'm going to show it. Right? I'm going to split these up by showing it like this one would be 2 times 20, and then you still got the x squared, right? Okay, so I'm going to show that I'm actually splitting these into their factors with one of the factors being 2. 46, that'd be 2 times 23, which we said before, 2 times 23. And again, the x and the y there, we're not concerned with those variables. Right now, we're not concerned with them. 12, that'd be 2 times 6. And then we got the y squared, okay? So these 2's, I'm going to factor out from the 3 terms out. Okay, so what do we got left? Well, you got the 20x squared, the first term. And then you got the positive 23xy, second term. And then you got the 6y squared as our third term, okay? Now, I'm going to continue. Even though, yeah, we got this y squared. I don't really care that it's there. Like whether these y and y squared is there, it doesn't matter. Okay, I'm just going to look and follow the same rules that we've been looking at, which now would be like taking the first coefficient 20. I'm looking at just on the inside of that parentheses there, and then the final coefficient, which is 6. Multiply these together. Okay, so I'm going to get 120 out of that. So let's look at factor pairs of 120. 1 and 120, that's no good. That's not going to get us anywhere near 23. How about 2 and 60? Not quite. 3 and 40, we're getting closer. 4 and 30, even closer still no good though. And then 5 and then, 24. That's close, but we're still not there. 6 and 20, nope, still no good. 7, I believe it is divisible by 8. 8 and 15, that should work. Now, of course, it's divisible by 10. I believe it's divisible by 9 as well, but, oh, it's not. 10 and 12. Okay, so that would be it right there. And so, again, we look at all these factor pairs and see if there's any pairs that when we add, we need to get 23, our middle coefficient there in orange. Of course, 1 plus 120 is 121. 2 plus 60 is 62. And that's why we're saying we're getting closer and closer. But yeah, I guess for this one, it's kind of more towards the end there. So again, I am showing more work perhaps than I think anyone would want to show, but I do hope it helps. There it is, 8 plus 15, 23. It's like you guys were saying, so, and then 10 plus 12 is 22. It's pretty close, it's just not good. It's not gonna get us there, okay? So none of these ones work. We need the one that gave us a sum of 23 right here. So 8 and 15, right? So that means my middle term, 23xy, I will split into 8xy's. positive, and then also a positive 15 xy's. Everything else stays the same, 20x squared, and then a positive 6y squared. This is still in parentheses, and we still have already pulled out that 2 there in the front. Okay? All right, now we're looking for factoring by grouping, which let's go ahead and start on that. So our first group right here, the 20x squared plus 8xy. I know you can, from that, you can yank out an x at least. And again, we're still operating within this large set of parentheses. But also, the 20 and the 8 are both divisible by 4. Not just 2, but 4 as well. So I'm going to yank out a 4 from each of the 2 terms. So 20x squared then becomes 5x. Okay, 20 divided by 4 is 5, and then we yanked out one of the x's, right? And then from the 8xy, we pulled out a 4, so that would leave us with a positive 2. We pulled out the x, but we still got the y, okay? Now this still is pretty unusual for us right now, especially while we're still getting used to factoring. So, but still, we factor out the 4x. I don't see anything else that I could factor out here, so I should expect to be seeing over here also a 5x plus 2y in parentheses, okay? Now let's see if that pans out for us, okay? So the 15xy, of course we can factor out a y from both those. Give myself a little bit more space, but 15 and 6 are both divisible by 3, okay, and that's a positive 3. So what do we got left? From the 15xy, 15 divided by 3 is 5. We pulled out the y, but we're left with the x. See, it's already starting to match. And we pulled out a y from the 6y, so of course we got a y left from the y squared, but 6 divided by 3 is 2. Yep, that matches as well. That's kind of what we expected here. Yeah, we still got the 2 out there in the front. I'll show it now. So technology works. There we go. Okay, so we got this. And then we factored out a 5x and a positive 2y. And then we got the other 2 values that were part of those factors, the 4x and the positive 3y. Okay, now, like I said before, on that last problem, or not 2 problems ago, I should look to see if there's anything I can factor out from these 2 binomials. Yeah, 5x and 2y, nothing to factor out there, no common factors. Or 4x and 3y, no common factors there either. So that's just, that's going to do it for us on this one. Don't forget the 2 out there in the front either, though. We will need it. Now, this is the last problem in our lesson for this section. And, you know, is this work really hard? I don't think it's super difficult. It's just new, right? So it may feel like it's difficult, but, you know, like splitting up a 23xy. You saw this process right here, 120. I got up to like the 5, right? And I had to use my calculator to figure out these other ones. I hope you do the same because it knows. It knows. We don't need you to do any long division to figure out these factor pairs like this.